Okay, this is a quick example of the properties of vectors. In this question, what we're going to look to do is we're just going to look to simplify this. Okay, the question asks us just to simplify. So essentially what we're going to do is we'd use a distributive property to start. And the reason being is technically, if we think of our bed mass, we deal with the brackets first. Okay? But, oh, I did forget to write this in. I apologize. These are all vectors. This is vector I, J, K, J, K. Okay. Bed mass. So we look inside of the brackets. Are any of these technically parallel vectors? Do we know? Can we say for sure they are? No. They're represented with different letters. There's a possibility they might be parallel vectors, but usually we don't write it that way. We're going to get into what I, J, and K stand for later with its unit vectors. But essentially what we got is, it looks like three different variables, you could say, or in this case, three different vectors. So we can't combine them. I can't simplify inside the bracket, and same with the other bracket. So the next step in bed mass would be exponents. We don't have any exponents, so we then move to division and multiplication. There is no division, but there is multiplication. We have this scalar on the outside. Okay? So this is just a number of a value. We have no direction to it. But what it will do is when we put the scalar to each of these, it will change the possibly direction and length of each of these vectors. So we're going to use what's called the distributive property. We're going to distribute this 3 inside all three numbers of the brackets, which I'm sure you guys have seen before. And we're left with negative 3 vector I plus 15 vector j plus 6 vector k. And the other one, we have a negative sign, so we have to also apply that negative sign. Negative 2 times vector j gives us negative 2 vector j, so that changed the direction of vector j. And negative 2 vector k. Same idea. It lengthened it by a factor of 2 and changed its direction. Okay. But really all we have to do is simplify this. So I now look to collect some like terms. We have I, oh no, that's a j. I can't even read my own writing. We only have one I, 2 j's, and we have 2 k's. So we're going to simplify this. We still have negative 3 vector I, and this one plus 13 vector j, and plus 4 vector k. And that is the simplified version of this. We just used some old algebra rules to simplify this. We have 3 different vectors with different scalars in front of them.